The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
For number 2, letter A, we're supposed to find all solutions of this equation in 0 to 2 pi, so that just means in one rotation. So what you can see here is that we have a function that includes, or we have an equation that includes sine. And in general, when you're trying to solve a trig equation like this, you want to get the trig function by itself. So let's try to isolate that. We can add square root of 3 to the other side and divide by 2 to get this. So this is the most simplified version of our equation before we actually need to solve it. So here's something interesting about this particular equation. Now root 3 over 2 is a common result of a sine that you should know. That happens at pi over 3 reference angle and a variety of other rotations depending on our question. So what's important to note about this one is that we have a sine of 2x, not sine of x. If this was just sine of x, it would be pi over 3 and 2 pi over 3 because it's first and second quadrants where sine is positive. However, that's not the case here because we have a 2x in there. So we know that 2x has to be equal to our normal angles that would give us root 3 over 2. Like I just mentioned, pi over 3, 2 pi over 3. The tricky part about this is when you have a coefficient in front of your x in a trig function like this. That is how many times the number of answers you have. So we will have double the number of answers that we normally have if this was just sine of x. So what I'm getting at here is we can't stop at pi over 3 and 2 pi over 3. We need to actually check another full rotation. So pi over 3 and 2 pi over 3 are here and here. Now these two are negative, so we definitely couldn't use that. But what happens if we went all the way around and then did another pi over 3? So that would be fully around is 2 pi, or 6 pi over 3. One more is 7 pi over 3. And then one more to get to the second rotation of this one is 8 pi over 3. So you can see what we ended up doing here is just adding 2 pi to each of these. These are the first 4 solutions to this value. So you might be wondering, well, how can we use these? They're outside of 2 pi. We actually don't have the answers yet because our correct answers are when we divide all of these by 2. When we divide them by 2, they will be in our rotation, and that's what matters about that. So x is equal to pi over 6, 2 pi over 6, or just pi over 3, 7 pi over 6, and if we divide that by 2, we get 8 pi over 6, which is 4 pi over 3. So you can see, once we've divided by 2, all 4 of these obey that they're in 0 to 2 pi, so that's fine. So these are your 4 solutions to this equation. So whatever, if you have a number in front of your x, a coefficient on it, and a trig function that you're solving, that is always how many times the number of answers you'll have, and that's how many full rotations past the first one you need to check before you end up dividing. So if this was a 3x, we would have had to have put 6 things here, and then when we divided them all by 3, they would have been back in the first rotation, which is what needs to happen. So if you're skeptical about that, you can always check these by plugging them in and seeing if it gives you root 3 over 2, and they definitely do. So just be careful when you have coefficients in front of your x's when you're solving trig equations.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.